Welcome to this explainer. Today, we're zeroing in on an absolutely critical area for construction inspectors, QC personnel, and, well, anyone gearing up for the ACI Shotcrete Inspector exam. We are talking all about layers, joints, and intermediate surfaces in shotcrete applications. If you've ever found yourself wondering exactly how multiple passes of shotcrete somehow come together to form one solid monolithic structure without hiding any nasty defects inside, you are definitely in the right place. So let's dive right into this and build a rock-solid practical mental model for your field inspections. Here's our game plan for today. First up, layers and intermediate surfaces. Second, we'll look at curing compounds and bond. Third, we tackle planned construction joints. Fourth, I'll share a super handy 4-question inspector's framework. And finally, we'll run through some real-world field scenarios to really test your knowledge. All right, jumping right into Section 1, layers and intermediate surfaces. We really need to understand what's called the receiving surface principle. So, out in the field, shotcrete is very often built up in multiple passes, right? Whether you're dealing with a massively thick wall, an overhead application, or maybe a heavily congested reinforcement section, you're going to see multiple layers being shot. But listen up, because this is a major exam alert. Every single new shotcrete layer creates a brand new receiving surface. All those strict surface prep rules, they don't just apply to the original substrate, they apply between every single pass. You literally always have to start with a fresh, clean intermediate surface. Let's compare a good practice with a bad one. Good practice is pretty straightforward. You want a clean, sound surface. But bad practice, that's when you leave trapped rebound, overspray, and latents behind. That milky, weak layer of cement dust and water. Leaving that kind of debris behind creates a hidden defect. It's basically a weak internal plane that's buried forever inside the structure. Even if the crew is shooting wet on wet before the previous layer has fully hardened, they absolutely still have to keep that surface free of loose material. But what happens when things don't go perfectly and the surface isn't fresh? Look, once a layer has hardened, you have to treat it exactly like existing concrete. You need to remove all the weak material, provide the required texture, and, crucially, bring it to a saturated surface dry, or SSD, condition. Doing this ensures the hardened surface doesn't just suck all the moisture right out of the fresh mix. It's the exact same bond logic we use for shooting against existing concrete walls. Moving on to Section 2, let's see how this whole concept shifts when we introduce curing compounds into the mix, and why evaluating compatibility is a game changer. Curing compounds are fantastic for moisture retention on a completed final surface. We love them for that. But if more shotcrete is coming later, certain compounds are a massive red flag. Using a curing compound that acts as a bond breaker is literally like trying to put duct tape on a greasy floor. The next layer just won't stick. You have to verify that the curing method is compatible with future layers and strictly follows the project documents. Bottom line, never assume a final finish curing method is suitable for an intermediate bond surface. All right, Section 3, planned construction joints. Construction is messy. A joint is really just a planned, or sometimes unplanned, stopping point where placement is going to resume later. Got another exam alert for you here, and it's a huge one for your daily field checks. Avoid weak feather edges. When a crew tapers off the shotcrete into a super thin, feathered edge, that instantly becomes a major defect point. Those thin edges dry out incredibly fast, and they are practically impossible to compact properly, which means the material just crumbles away. If a specific angle is required for the joint, it needs to be cut and roughened while the shotcrete is still plastic, way before it becomes too hard to shape. Let's switch into inspector view for a second. When you're looking at a joint, don't just stare at the concrete face. Zoom in on the steel crossing that joint. Overspray loves to collect on the exposed rebar near these stopping points because, well, the crew was just shooting right next to it. That steel absolutely must be properly cleaned before placement resumes, because if it's coated in hardened overspray, the new shotcrete cannot fully encapsulate the rebar, and you've got a structural problem. And of course, the reality of the field is that things go sideways. Equipment breaks down, concrete trucks get stuck in traffic, or a sudden thunderstorm rolls in out of nowhere. This brings us to unplanned interruptions. If a delay goes on long enough for the material to set, the resulting interface can no longer be treated as a fresh layer, period. It must be treated as a construction joint. The crew cannot simply restart shooting over a hardened edge without doing the required prep work. As an inspector, your job is to identify the exact moment a normal, harmless pause turns into a hardened joint condition. To help you manage all of this amidst the chaos of a busy job site, let's look at Section 4, the inspector's framework. I want to give you a really solid mental model to run through before every single layer goes up.
Think of this framework as your field's superpower. It's just 4 simple questions. Step 1, what should I see? In your head, you should be visualizing a sound, perfectly clean intermediate surface fully prepared for the next placement. Step 2, what am I actually seeing in front of me? Are you looking at a mess of rebound, latents, weak edges, or maybe some curing residue? Step 3, why does it matter? It matters because that specific interface could become a weak internal plane, totally compromising the structure. And finally, step 4, what action is required? Usually it's stepping up and stopping the work to prepare the surface according to the project documents before that nozzleman even thinks about pulling the trigger again. Asking these 4 questions constantly is how you prevent hidden internal defects.
Okay, it's time to put that brand new framework to work. Let's dive into Section 5, Real-World Field Scenarios. I'm going to present a situation, and I want you to think about what you, the inspector, should notice. Scenario 1. Picture this. The crew places the first half of a thick wall in the morning. They take off for lunch. When they get back, the exposed shotcrete surface has partially hardened, and the wind has blown a fine layer of rebound dust all over it. But the crew is behind schedule, they're in a huge hurry, they grab the hose, and they want to continue shooting right this second. As the inspector, what should you notice?
Well, you have to step in right away and verify the condition. Ask yourself, does this surface still qualify for a wet-on-wet continuation? No way. Because it's partially hardened and dusty, it has officially crossed the line. It must be treated as a hardened intermediate surface and fully prepped before they can continue.
Let's try Scenario 2. Yesterday's placement stopped at a properly cut, nice rough edge. Today, you show up, check the concrete surface, and it looks perfectly sound and clean. But the exposed reinforcement near the joint is completely coated with hardened overspray from yesterday's work. What should the inspector notice here? Remember that inspector view we talked about earlier? The joint face is only half the inspection. The action required here is making sure that the reinforcement is also ready and cleaned. You absolutely cannot let them shoot over dirty rebar, or the structural integrity of that joint is going to fail. All right, final scenario. Scenario 3. The contractor applied a curing compound to a completed surface at the end of the day yesterday. But the next morning, there's a sudden change of plans. They decide they actually need to add another shotcrete layer over that exact same surface. What should you notice? You've got to catch this compatibility issue immediately. The required action is to pull up the specs and verify if that specific curing compound is compatible with the required bond. If it acts as a bond breaker, which, let's be honest, many of them do, it must be completely removed through mechanical preparation before any new material touches it. Chemical removal usually just won't cut it. And that brings us to our final takeaways for today. Remember, every single layer needs a sound receiving surface. Absolutely no trapped rebound or overspray. Always prep hardened joints according to the spec. And a major field rule, never assume yesterday's good shotcrete guarantees today's good bond. If you consistently apply this mindset, you are going to catch defects way before they get buried. So, I leave you with this. The next time you walk past a massive, seamlessly finished concrete wall, ask yourself, just how many hidden layers are lurking beneath that smooth surface, and were they actually prepared properly? Thanks so much for joining this explainer. I'll see you in the next lesson.